Let us look at operations on the stack. So the first operation is push. This operation is used for inserting an element in the stack. So let us see how to insert an element in a stack using array. Initially, top pointer is pointing at -1, means there are no elements in the stack. So let us push a value. I want to push an element 10. So increment top pointer, move top. So how to increment? As it is an integer type, so say top plus plus, it will move here. Then at s of top, write down a value. Then I want to insert one more value, 15. So increment top pointer, top plus plus, top will move here and insert the value at s of top, that is s of 1. Top is 1 now. So s of 1, insert a value. I'll insert few more values. So right now top is here, which is at index 3. I want to insert one more value, that is 20. So yes, increment the top pointer and insert the value 20. Now this is important. I want to insert one more value, 25. Can I insert? Is there any free space available? No, there is no free space. I cannot insert because top is equals to 4. 4 is what? Size minus 1. So it means stack is full. So before insertion, actually I must check whether the stack is full or not. If it is full, I cannot insert it. If it is not full, I can increment top pointer and insert an element in an array. So that's all. This is the procedure. Check if it is full. If it is not full, then insert an element. Let us write a function for doing this. I will write a function push. This should take parameters. Two things. Now let us write a function for performing push operation. Push is the function name. What are the parameters it needs? It needs a stack in which we want to insert an element and what the element we want to insert. So two parameters are required. First one is stack type, that is this type of structure. Let us take it as st and also a value. Now one important thing, this push function should insert an element in this stack only, the one that is passed. So if you want to modify the same stack, then it should be called by address, that is called by reference. I should write a pointer here. Then what this function is going to return? Nothing. Let us call it void. So this is the prototype of a function. Now inside the function, first thing what I have to do, I have to check for this condition whether the stack is full. Means if the stack is full, I cannot insert any element. So let us check the condition. So top is equals to size minus 1. This is the condition for stack full. But I have used st. Yes, these two are inside this structure variable, that is st, and here is a pointer, so I have to use arrows. So this st is a variable of this type, this structure. So there are two members here, size and top. Those members I am accessing, and this is for the array. This all we have already studied. So they are inside the structure, so I have to access them by using structure name. So first condition is top is equals to size minus 1. If so, then the stack is full. If I try to insert anything, then it is overflown. So I'll give a message that stack overflow. So if it is full, then say stack overflow. Otherwise, we can insert the value. So what is the method for insertion? We have already seen that top was incremented and the value was stored. Suppose this is not there, I am storing top. Then how to insert? First increment top. So where is the top here? st is having top. See, this is top, right? So that's member. This is the member. So say st is top plus plus. So top is incremented. This will move the top to the next location. Then here I have to insert an element, that is s of top. So where is s and top? Both of them are this in structure. So I have to say st is s, then st is top. And here the value x is stored, the value that we want to push. See, actually this is s of top, but both are inside structure. So I am writing st is s and st is top. So this is the style of code we will be writing in the remaining functions also. So remember that these things are inside the structure which we have already discussed. So this is the method for pushing a value. Now let us look at next operation, that is pop, deleting a value. Let us see the procedure for deletion. If I want to pop out a value, right now top is pointing here and this is the topmost value. So take out the value and decrement the top pointer. The elements are till the place where top is pointing. So these are the values present in the stack. Then I want to delete one more value. So take out the value and decrement the top pointer. I'll delete few more. Delete this value, top is decremented. Then I want to delete this also, top is decremented. Take out the value and the top is decremented. So top became what? -1. Now top is -1. Can I delete any more values? No, there are no values. How do you say there are no values? Stack is empty. How we say stack is empty? Top is equals to -1. Yes, top is equals to -1. Stack is empty. So before deletion, we should confirm, are there any elements present in the stack or not? If there are no elements, we cannot delete any element. If we still try to delete, then we say stack underflow. So let me write down a function for deleting a value from the stack. Function name is pop. If I want to modify the same stack, then I should pass it as reference or address. So it's of that type structure, stack star st. So I'm taking a pointer. So this pointer will be pointing on this stack. Example is the stack. So using the pointer, I'll be accessing all these members, that is size and the top and s. Now what this function should do, delete and return the value. So return type should be the type of values present in the stack. So we have integer type values in the stack because this array is integer type. So return type is integer. First thing what I should do, I should check whether I can delete any value or not. So it means I should check whether the stack is empty. If it is empty, I cannot delete. So first condition I will check if stack is empty. So what is the condition? Top is equals to -1. So I cannot say top directly. I have to say st stop. If st stop is equals to -1, then I should give a message that stack underflow. So stack underflow. If top is equals to -1, then stack underflow. Else, what I have to do for deleting? Else, take out the value from this place, s of top, take out the value. So for that, I will declare one variable x and also initialize it with -1. Why -1? I will show you. Now I will take out this value 15 and store it in x. So say x assign s of top, but both of these members can be accessed using pointer. So I have to say st is s, then st is top. So this is st is s and st is top. The value is taken in x. So if there is x, then suppose this is x, the value 15 is copied here. Then decrement top pointer, top minus minus. So we assume that this value is deleted. So I should decrement the top pointer. So st is top minus minus. Top pointer is decremented. Now finally, the value that is taken out from the stack, I should return it. So return this value that is present inside x. Here I write return x. So value is returned. Now one more thing, if the stack is empty, then there is nothing to delete. Then what this function will return? It is returning x. So if nothing is deleted in x, else part is not executed, means it will return -1. So if this function is returning -1 means stack is empty. There is nothing to delete. Otherwise, the deleted value. So like here, just now we had 15, so we got 15. If nothing is there, then it will be -1 only. That's all about push and pop. Now one important thing we have to discuss. What was the time taken for pushing an element? Just incrementing the top pointer and writing a value. So the time was constant. What is the time taken in deleting an element, popping an element? Just take out a value and decrement top pointer. If else, these simple statements are there. So it is constant, time is constant. So earlier I have written push, that was also similar. So that time is also constant. So the time taken by push and pop operations is constant. Remember this. Now next operation is peek operation. Now next is peek operation or peep operation, finding an element at a given position. So inside the stack, what is the element at first position? As I already told you that this element is set to be first element. So position 1, then position 2, position 3. So if I give position 2, then I should get 8, right? If I say position 4, then I should get element 10. So actually if you see the indices in an array, this is index 0, 1, 2, 3. So the indices are moving up from here. But position means we have to start from top. So we need some formula to map this thing. So let us take some examples and study how we can build up a formula for this one. If I say position as 1, then what should be the index? 3. It should be 3. If I say position 2, then what should be the index? 2. If I say position 3, then index should be 1. If I say position 4, then index should be 0. How I can obtain this? So I think this top pointer can help me to find out the indices. So for position 1, I want index 3. So how it is possible? See, top is a 3. From that position, if I subtract 1, so actually I want the index 3 here, right? So okay, add 1 again. Let us see. Let us try this. Will it work for others also or not? See, top is a 3 and 2. 2 means position I want as 2. So 3 minus 2 plus 1. How much this is? This is 2. So okay, I got it. Then position I want a 3. So top is 3. 3 minus 3 plus 1. This is 1. And fourth position is what? 3 minus 4 plus 1. So this is 0. So yes, it is working. So with the help of top pointer, I can get the index in an array. So this should be taken as 3 minus 1 plus 1. That is, the answer is 3. 3 minus 2 plus 1. And 3 minus 3 plus 1. 3 minus 4 plus 1. So this index can be obtained by top minus position plus 1. So this is how I have obtained the formula from observation. By observing these positions and the top pointer, I have obtained the formula. So using this formula, we can convert the position into an index in an array. Let us use this formula and write a peek function. Function is peek. Then it needs a position. Which position element? And also it needs a stack. So I will send this stack as a parameter to this one. Function is peek. It needs a parameter as a stack. So I'll pass a parameter as a stack of this type. So stack st. See, I should write struct stack st, but in short I am writing just stack st. Then this should be called by reference or called by value. See, call by value is enough because here we are just reading the contents of the stack. We don't want to modify it. Second parameter, we want the position. So position. Then it should return a value found there. Okay. Then let us write the code here. Whatever the position is given, I should get the index using this formula and return the value from there. One more thing I should take care whether the position is given valid or not. Right now there are 4 elements. So if I say I want to look at 6th element or 10th element, it's not there. So first of all, I should check if that position is valid or not. So if top minus position plus 1, this formula should not give any value less than 0. So if it is less than 0, then I should give a message that position is invalid position. Otherwise, I can return a value at a position, so and so position. So I will take the value in some variable and return it. So for that I will declare a variable x and also initialize it at -1. Then else I will take the value. So x assigned from where I want the value. S of this formula. So this is inside st. So I should use this structure name st.s and st.top. So let me write it. X assign st.s of st.top minus position plus 1. So I have used the formula. So here also I should write down same thing, that is st dot. I have directly written this one. So st dot. Now finally return the value that you have found. So that is present in x. So return x. If the value is not found, an invalid index, then it will be returning -1. So if this function is returning -1 means value is not found. That's all with the peek. Now analysis. What is the time taken by this one? So the time taken is constant. The statements are very simple, just if and else and some formula is there. So the time for this function is constant. Now quickly let us look at 2 more functions that are isEmpty and isFull. Let us look at remaining functions of a stack. First one is stack top. Just we want to know what is the topmost value in the stack. For example, here the topmost value is 20. So wherever top is pointing, we want the value from there. So here is a function stack top. It takes stack as a parameter, this whole thing as a parameter. This whole thing means the array, size and top. That's the structure which we have already seen in the beginning. So that whole thing it takes and check if top is equals to -1. If it is -1, then stack is empty. There are no elements. So this function returns -1. Otherwise, there are some elements. So wherever top is pointing, so it should return this value, So what is this value? S of top value. But this is inside structure st, so it should be st.s of st.top. So st.s of st.top, it should return this value. So that is stack top. And there are simple statements, so the time is constant. The next function is empty. This is empty. It takes stack by value, not by reference, because we are not going to modify this. So this is taken as a variable st. Then st.top, if it is -1, we know the condition, stack empty condition. This is stack empty condition. If it is -1, then stack is empty. Yes, it is empty. So return true. So we know well that in C language, true and false, true means 1 and false means 0. So true, it is returning 1. Otherwise, return false, that is 0. Then stack full. It will check whether the stack is full or not. If it is full, it will return true. Otherwise, it will return false. So it's taking this stack by value. So it is taking this stack by value, and here it is checking whether top is equals to size -1. And both are inside the structure. So st.top is equals to st.size -1. This top is equals to size -1. If yes, then return true. So true means non-zero value in C language, so it is returning 1. Else stack is not full, so return false, that is 0. So 0 is false and any non-zero value is true. So we prefer taking 1 as true. So we have taken 1 for true and 0 for false. The time taken by all these functions is constant. So all the operations we saw on the stack takes constant time. That's all about stack using array.